let's use the ratio test on this series. This is my a sub n term. So my a sub n plus 1 term is going to be negative 1 to the n plus 2 times 3 times n plus 1 plus 4 over n plus 1 squared. So I want to take the limit as n goes to infinity of a sub n plus 1. Now I'm taking the absolute value, so I'm going to ignore the negative 1 part. And I'm going to do a sub n plus 1, which is 3 times n plus 1 plus 4 over n plus 1 squared. Multiply that by the reciprocal of a sub n, which give me n squared on top and then 3n plus 4 on bottom. And now rearrange to put like things together. This 3 times n plus 1 plus 4, I'm going to go ahead and distribute that out. So I get 3n plus 7. And then underneath it, I get 3n plus 4. And then n squared over n squared plus 2n plus 1. I'm taking this and I'm foiling it out to get there. All right. If I wanted to be formal, I could write in another limit here. Split this into two different limits. But most of the time I'm not going to do that, so I'm not going to do it here. I'm just going to evaluate these limits individually. This one over here gives us 1. This one over here also gives us 1. So what we get here is the limit is 1. Now what does that tell us? It tells us the ratio test is inconclusive. All right. So here's what I should probably do then. Going back and looking at the original series, we've got, I'm going to recopy it down here so that it looks a little nicer, but we've got negative 1 to the n plus 1 times 3n plus 1, or no, plus 4 over n squared. If we look at the absolute value of this, so one thing you notice, this is an alternating series. So can we use the alternating series test on it? Well, if we take the limit as n goes to infinity of 3n plus 4 over n squared, that does give you 0 because the bottom's going to grow faster. Well, what I'm doing here is I'm attempting to use the alternating series test on it. And these terms are shrinking to 0. So therefore it converges. But that's only sort of a partial answer. Is it absolutely convergent or is it conditionally convergent? To answer that, what we've got to do is take the series we get by looking at the absolute value. So if I look at this 3n plus 4 over n squared, we can compare that to 3n over n squared, which turns into this. This we know diverges. Okay, that series diverges. And if you compare this with this over here has a larger numerator. So therefore, it has a larger numerator than this. And if this thing diverges, and this is larger numbers, it has to diverge as well. So the original series we had converges. When we take its absolute value, we get something that diverges. So that means that the original thing was conditionally convergent.